Yeah, hi. This video is on decision analysis for Business 370. So I want to start by really explaining what is the decision process is and go through an example talking about the perspective-based criteria. And in other videos and follow-up videos, we'll talk about other criteria. So the decision analysis process involves these steps: define the problem, identify the alternatives, determine the criteria, develop a model, evaluate the alternatives, choose an alternative that optimizes the objective function. So in doing so, we need to identify the decision alternatives, states of nature and resulting payoffs. And once we identify those, the decision alternatives are different. You can recognize that they are different possible strategies the decision maker can employ. The states of nature, they are really referred to future events that are not under the control of the decision maker, while the decision alternatives, they are under the control of the decision maker. States of nature should be mutually exclusive. We'll talk about that in a little bit. So let me start with this example here, which to illustrate all the ideas. We have the problem we have is this is the scenario or the mental model. A carnival is scheduled to appear in a city on a given date. The profits are obtained are heavily dependent on the weather. If the weather is rainy, the carnival loses $15,000. If it's cloudy, it loses $5,000. If it's sunny, it makes $10,000. There are of course, the carnival has to set up equipment, but can cancel prior to the show, and this action results in a loss of $1,000. Also, we're going to use the weather forecast has compiled these probabilities for our possible forecast, which said that 10% chance of rain, 30% chance of clouds, and 60% chance of sun. So how would you make a decision in the face of this uncertainty of the weather forecast? So let's see how we set up this problem first. In this case, we identify the controllable variables, which are the decisions we can make. So we can either set up or we decide not to set up and incur the penalty. Of course, if we set up, then these are the uncontrollable variables, which are the state of nature, will control our payoff. And these three states are rain. We're going to use S1 for rain, S2 for cloud, and S3 for sun. Now, because the uncontrollable variable is the weather forecast, so it's a source of randomness, uncertainty. We don't know whether it's going to be rainy, clouds, or sun on that day. So we can associate with this a probability distribution. Basically, the weather forecast looks at similar days from past history and identifies 10% chance of rain, 30% chance of cloud, and 60% chance of sun. And you can see that's a probability distribution. If you recall from your probability class, probability distributions have to have probabilities between 0 and 1 and add up to 1. And then now we have the payoff table. So we're putting all this together. We have this payoff table. Here we have the states of nature, rain, cloud, sun. Here we have the decisions on the rows, set up or do not set up. And these are the payoffs for each of combination of decision and the state of nature. So if on the day, if we decide to set up and it's rain, we lose $15,000. We lose 5 if it's cloud. We make $10,000 if it's sun. If we don't set up, we lose $1,000 if it's rain, cloud, or sun. Okay, so now how do we make a decision? There are different ways of making decisions. One class of decisions criteria we're going to talk about in this video is the perspective based. We notice here in this table we did not identify the probabilities of the states of nature. Suppose we don't know what those probabilities were, and so we have to make a decision. Then the decision will depend on the decision maker being optimistic or pessimistic or some combination of each. So we can identify some of these criteria. We call them perspective-based decision makings. In a follow-up video, we'll talk about probability-based decision making. All right. So for now, the first criterion is called the max criterion, or sorry, the max min criterion, and this assumes the worst case of the state of nature will occur. Basically, this is for a pessimistic individual, and the way it works is we look at the payoff table and then pick the worst payoff for decision one, which is losing $15,000. So that's called the raw minimum. In this case, that's the minimum value. And then if we decide not to set up, we look at the worst payoff, which is 1,000 in either case. And then we pick the maximum of these two, because the negative losing 1,000 is better than losing 15,000. So this is the maximum. And that means our decision, call it D star, is D2, which is do not set up. On the other hand, if a person is optimistic and assumes the best case state of nature will occur, we call that the max criterion. Okay, and in this criterion, same as the previous one, except now we pick the maximum value for each decision. So for this decision setup, we pick the maximum, which is 10,000. In this case, the maximum would be negative 1,000. And then we pick the maximum of the maximum. The higher of the two values is 10,000, and that corresponds to D1, which is set up. So in this case, our D star would be to set up, and you can see how the two different criteria led to two different decisions. Now there's another criterion called the min-max regret criterion, which basically we transform the payoff table into a regret table, and then pick the decision that minimizes the maximum regret. So regret is the deviation from the best possible outcome. So we can define that as P star of Sj, where P star is the best possible outcome for each state of nature, and subtract the payoff from the other values. So if I go here, S1 is rain, my best possible payoff would be 1,000 for D2. For this one here, so that's basically what I would regret if it happened to be rainy and I decided not to set up, then there's nothing to regret here. So it's this minus negative 1,000 would be 0. But if I decided to set up, what I would regret is this amount minus this amount, which is $14,000. The same thing here. If it's clouds and I decide not to set up, I regret nothing because I made the right decision. If I decide to set up, then I would regret $4,000, which is the difference. And the same thing here. If it's sunny and I decide to set up, I made the right decision. My regret would be 0. If I decide not to set up, then I'm going to regret $11,000, $10,000 that I would have made plus the 1,000 I pay in penalty. So putting all these things together, I would create, and using this formula here, which is exactly what I said, I would create this regret table. And now I want to minimize my regret, my maximum regret. So what's the maximum regret if I decide to set up? So I regret 14,000 here, 4,000 here and nothing here. So my maximum regret is $14,000 if my decision is set up. If my decision is do not set up, I regret nothing here, but I regret 11,000 here. So my regret would be 11,000 here. So if I decide to set up, my worst case would be to regret $14,000, while if I do not set up, my worst scenario is to regret $11,000. I want to minimize that regret, so I pick the decision that corresponds to the minimum of these two values, which is to minimize my maximum regret. Okay, in this case, do not set up. One more criterion. It's called the principle of insufficient reason. Basically, this assumes I have no reason to believe one state of nature will be more likely to happen than others. Remember, the optimistic person picked sunny, the pessimistic person picked rainy. So I don't know which one to pick. I'm really neutral. So basically, I just look at the average in this case. So we go back to the payoff table, add, if my decision is to set up, I add all these three and divide by 3. So the sum is negative 1,000, 10,000, and the average would be 3,333 loss. If I decide to set up, I add all these three, which gives me this value, and then divide by 3. So my average payoff would be a loss of 1,000, and so the maximum is this. I would be better off with not set up. So my decision is do not set up. Okay, so that's my these are my criteria for perspective-based decision making. In the second video, we'll talk about probability-based decision makings, where we know the probabilities of the state of nature, we factor them in and look at the expected value criterion. Okay, thank you.